Hello dear students, welcome to our learning program Ready to Learn, produced by Rwanda Education Board in partnership with UNICEF and Inspire, Educate and Empower Rwanda. I'm teacher Jane and I teach Senior 2 Geography. Before we start, I would like to remind you that you should respect the measures of hygiene set by the World Health Organization and our Ministry of Health regarding the prevention of spread of coronavirus. Thank you. For our lesson, I hope you have a pen or a pencil, a notebook, a student book if you can get it easily, or any other resource that will help you during this lesson. Our lesson is on page 68 to 73 of the student book. Thank you. To start, remember we had a homework of carrying out a research and discuss 5 methods of soil conservation methods. To start, we had a homework of carrying out a research and discuss 5 methods of soil conservation. What did you come up with? Excellent! Some methods of soil conservation include terracing, which involves building embankments across the slopes, usually at fixed intervals. Terracing is a recommended measure for all hilly areas. We have it like in Kisaro, in Rulindo district, and in many other areas of hills in Rwanda. We can also use strip cropping. This is the practice of planting alternate strips of grass and crops across the slope and at right angles to the natural direction of the slope. We can also use fertilizers. In general, artificial fertilizers replace the lost nutrients and improve the quality of soil. They also improve on the crumb structure. This makes the soil loose and reduces the likelihood of being eroded. Another method is crop rotation. Crop rotation is the growing of different crops on the same piece of land for successive years in a sequence or a cycle. We can also plant cover crops because their leaves spread on the top of the soil and protect it against the impact of raindrops and the effects of winds. So as you see, we have different methods of soil conservation. Dear students, today for our lesson, I want you to be able to define weathering and mass wasting, identify their different forms and how they occur, their effect on the landscape and on human activities, and how to prevent the negative effects. To start, I want you to use your previous knowledge and think of the difference between soil erosion and weathering. Then, which of them comes first? Excellent! Weathering is the disintegration of rocks or decomposition of rocks by natural agents. Weathering is the soil formation process, while soil erosion, as we saw it previously, is the removal of the topsoil by agents of erosion such as wind, water, or ice. Students, this means that weathering comes before soil erosion. We have 3 types of weathering: mechanical, chemical, and biological weathering. Let's start by mechanical weathering. This is the physical breakdown of rock material without any alteration in its chemical composition. There are no changes in the constituent minerals making up the rock. The main agent of mechanical weathering is temperature, while chemical weathering is the type of weathering involving changes in the chemical composition of all the minerals making up the rocks. This causes the rock to break down, fall apart or disintegrate, or some of the constituent minerals undergo chemical changes. Chemical weathering is facilitated by the presence of water, gases, and high temperature. The third type is biological weathering, after chemical and mechanical weathering. Biological weathering is the breakdown of rocks due to the action of living organisms, namely plants, animals, and people. The rocks are broken down through mechanical or chemical processes. Friends, we will discuss more these forms of weathering in the unit of weathering and rocks. I think this will be Unit 7. From details you have just got from the types of weathering, I want you to think of causes of weathering and write down 2 of them. Think of 2 causes of weathering and write down 2 of them. Excellent! The causes of weathering are climate, slope, plants, animals and human influence, time, the nature of the rock, and so on. Let's start by climate. The main element of climate that causes weathering are sunshine and rainfall. In fact, the amount of sunshine determines the heat responsible for expansion of the rock. This means that at night, contraction occurs with rocks. This rotation of expansion and contraction causes the rocks to break down into particles. Another element of climate that causes weathering is rainfall. Rainfall provides water that dissolves minerals, causing them to crumble. Some rocks absorb water, which enlarges and softens them. This causes them to break down easily. Another cause of rock weathering after climate is slope. After rocks have broken down, the slope determines the rate of removal of the pieces. This exposes the parent rock to further weathering. Some materials may flow down slope freely. Sometimes these materials may need to be swept by water. But on flat surface, the rate of removal is slow, so is the rate of weathering. Another factor is plants, animals, and plant influence. Organic acids released from the composition of plants and animals assist in chemical weathering, while plant roots grow deep into the ground, penetrating into rock joints. This opens the joints up, leading to physical weathering. Also, human beings accelerate the rate of weathering through activities such as digging and mining. Another cause, after climate, slope, plants, animals, and human influence, is time. This refers to the duration of rocks are exposed to agents of weathering. The longer a rock is exposed to agents of weathering, the greater the rate of weathering. Other causes include nature of the rock, mineral composition, among others. Thank you, dear students. Again, I want you to think critically. From your experience, from what you see in the environment in real life, what can be the impact of weathering on the landscape? What do you think can be the impact on weathering on the landscape? All right. The impact of weathering on landscape is broad. For instance, when the rocks seen on the Earth's surface undergo weathering, they reduce in size. The harder parts of the rock may remain protruding on the Earth's surface as the rocks wear down. Again, some rocky highland areas may also undergo weathering, leading to creation of flat-topped hills like plateaus in eastern Rwanda. Also, soluble parts of some rocks led to formation of holes in the surface. Water may disappear into such holes, which may further dissolve minerals underground. This creates underground caves. We have different caves like in Musanze, in Rwanda, and many others. Thank you, friends. Welcome back. Before we continue, let's do a short recap. What have we already seen from the beginning? Great! We have learned that weathering is the disintegration of rocks or decomposition of rocks by natural agents. We have also seen different types of weathering that are mechanical, biological, and chemical weathering. We have learned the causes of weathering and its effects on the landscape. Note that after weathering, the process of degradation of rocks will continue. This will be done through mass wasting or erosion. When we talk of mass wasting, this is the movement of weathered materials downslope under the influence of gravity. I repeat, mass wasting is the movement of weathered materials downslope under the influence of gravity. Mass wasting occurs when weathered materials upslope are lubricated by rainwater. The movement of materials during mass wasting may be slow or rapid. We have different types of mass wasting. We have soil creep, solifluction, earth flow, mud flow, and landslide. We are going to see each type, its description, the nature of slope, and the speed of movement. When you look at soil creep, this is the slow, almost continuous movement of soil that is lubricated by water on a gentle slope. The movement may not be noticeable. However, the effects are tethered trees, fences, or electric posts. The soil is also seen to accumulate at the foot of the slope or behind obstacles such as walls. This happens on very gentle slopes, and the movement will be slow. The second type, solifluction, this is a slow movement of soil saturated in water over a frozen ground or a moderate slope. The movement is common in mountainous areas and in very cold climates. This happens at moderate slope and the movement is slow. Like for soil clips, also the movement for solifluction is also slow. The third type of mass wasting is earth flow. Earth flow is the movement of weathered soil over a slope after lubrication from moderate rainfall. The soil gets saturated, then breaks away from the slope and flow downhill rapidly. This will happen in moderate to near steep slope areas, and the movement will be rapid. Then we have mud flow. Mud flow is the movement of soil over a slope after lubrication from heavy rainfall. This mainly takes place in arid areas and will happen in moderate to near steep slope like for earth flow. Speed of movement for mud flow is also rapid. Lastly, we have landslide. Landslide, because it is common in Rwanda, this is a sudden movement of large quantities of loosened materials down a steep mountainous slope on cliffs. It happens on steep slopes and the movement is rapid. Dear students, the movement of weathered materials down slope will depend on the weight of the weathered materials, the earth or tectonic movements, the nature of the materials, the angle of slope. It will also depend on human activities and many other reasons. Friends, again, according to what you always see happening around you. Think of the effects of mass wasting and say it loudly. I give you 20 seconds of thinking and you will say it loudly. According to what you always see happening around you, think of the effects of mass wasting. That's good. The effects of mass wasting are both negative and positive. The positive effect of mass wasting can cause fertile soils to move downslope, and this promotes crop farming downslopes. You will see, like in different valleys of Rwanda, how fertile the soil is. This is due to the soil coming from the slopes down and will promote farming there. The second positive mass wasting cause is that mineral deposits that may be underground get exposed upslope in areas where mass wasting originates from. Futures formed as a result of mass wasting can also serve as touristic attractions. On the other hand, we have some negative effects of mass wasting. For example, areas upslope that lose the fertile soils due to mass wasting lose fertility, making them unsuitable for crop farming. Also, rapid mass wasting may cause destruction of property, infrastructure, and even death of animals and people. Again, the materials that froze downslope may block roads, preventing transport. This happened in Ngororero, whereby the road was blocked due to materials flowing downslope. Materials carried downslopes may block channels in river valleys, and this can change the flow of rivers or form temporary dams. Finally, areas upslope that experience mass wasting may be prone to erosion. This is because the topsoil will have moved downslope, exposing the softer underlying soils. Thank you. Now, I want you to think as future planners because I know you are future planners. Now, as future planners, suggest some measures to control mass wasting and soil erosion. Excellent. Since the impact of mass wasting, especially landslides, is so severe, some measures can be taken to prevent accidents. For example, there will be creating public awareness on the need to conserve the environment to avoid cases of erosion and mass wasting. Also, gradients on steeper slopes can be reduced. Potentially unsuitable rocks or soil masses should be removed. Another measure is retaining walls or structure that can be built to hold back possible slides. Also, steep slopes should be inspected regularly, especially during periods of intense and prolonged rainfall. Again, construct more surface drainage channels and ditches. Subsurface drainage systems may need to be constructed or improved. Restrict development and building in dangerous zones and choose alternative sites for infrastructure development. Also, vegetation can be planted on steeper slopes. This means afforestation, agroforestry, among others. Instruments can be installed to check slope stability, providing early warnings in areas of concerns. These are some of the measures that can be used to protect or to prevent mass wasting and soil erosion. As we are concluding, let's take some minutes to summarize what we have learned. What have we learned today? Great! We have learned that weathering is the disintegration of rocks or the composition of rocks by natural agents. We have also seen different types of weathering that are mechanical, biological, and chemical weathering. We have learned the causes of weathering and its effects on the landscape. Then, we learned that mass wasting is the movement of weathered materials downslope under the influence of gravity. We saw that the movement of materials during mass wasting may be slow or rapid. We saw also that we have different types of mass wasting, including soil creep, soil deflection, earth flow, mud flow, and landslide. Dear students, we can't conclude without saying that human activities can impact the natural resources either positively or negatively. In order to maintain a perfect balance in our environment, we should use the environment thinking of future generations. Lastly, remember our objectives were to define weathering and mass wasting, identify their different forms and how they occur, their effect on landscape and on human activities, and how to prevent the negative effects. If you think we have tried, thumbs in the middle. And if you think we have failed, because this is also possible, thumbs down. With that, thank you for tuning in. I'm Teacher Jen. See you.